Hello, ladies and gentlemen. I wanted to go over Friday's exercise and how we got those answers. That will help you on today's assignment if you want to review. Okay. You can skip through portions of this video too. If you get portion A, but you didn't quite get portion B or C, you can skip ahead. So now we are working on portion A or part A. Okay, so first I'll go ahead and start reading the question. It says, Jordan and Wendy each got a new phone with some pre-installed apps. Jordan downloads 10 more apps and pays $1.49 for each he downloads for the duration of having the phone. Wendy decides to download 12 new apps and pays 99 cents each for any apps she downloads. Okay, so part A says, write an additive equation for each person to show the number of total apps they have on their phone given the number of pre-installed apps. Write a multiplicative equation for each person to show the amount paid for their apps given the number of apps downloaded. Okay, so first part A, let's do the additive. Okay, so y equals x plus a. That's what we're looking for. That's what we want our equation to look like for an additive equation. Y equals x plus a, where a is going to be the number of apps that he downloaded. Okay, all right, so let's see. Jordan, we'll do Jordan's first. This is Jordan. Okay. It says Jordan downloads 10 more apps and pays $1.49 for each. Okay. So we're not worried about the cost. We're looking at that 10 more apps. So y is going to equal x plus what? How many? X is going to be the number of apps pre-installed. Okay, and A is going to be the number of apps that he downloaded. Okay, so we know that he downloaded 10 more apps. So however many apps he has pre-installed, it's going to be plus 10. Okay, and so that was the equation for Jordan's additive equation. All right, let's check out. Let me change colors for Wendy. Let's check out Wendy. Okay, so Wendy, we're looking for an additive equation again. So it's going to be y equals, and it says she downloaded 12 new apps. So x plus 12. Okay, those are the two answers that you should have got for, I think it was numbers 1 and 2 on the Google form. Okay, y equals x plus 10 and y equals x plus 12. Make sure we put the y equals, okay? Some of y'all just put x plus 10 and x plus 12, but we want to make sure we complete the whole equation, okay? All right, let's move on to, we're still in part A, but we're going to move on to multiplicative equations. For a multiplicative equation, it's y equals ax, okay? Where a, this time, we are talking about, it says write a multiplicative equation for each person to show the total amount paid for their app. So we're talking about cost. So y, let me break this down real quick. Okay, so y is the total cost of all the apps. A will be the price per download, and x is going to be just the number of apps downloaded. So Jordan, let's start off Jordan. We're going to use the green for Jordan. So y equals, okay, and how much were the price for each one? It was $1.49. So y equals 140, excuse me, 49 x. Okay, and Wendy's is going to be y equals, and how much did she pay? 99 cents. So y equals 99x. Okay, so those are all those on part A. Those are the four equations you should have come up with. That would have been questions 1, 2, 3, and 4, I believe. 1, 2, 3, and 4. Okay. All right, part B. I've written our additive and multiplicative equations that we got for Jordan and Wendy over here to the left. Part B says create tables to represent the equations you wrote in part A. Okay, so let's go ahead and create our tables. Let's go ahead and do this one. Oops. Okay, so I'll set two tables up down here, and let's go ahead and get started. We know that these are going to be our x's and y's, right? X's and y's, and our rule is going to go right here in the middle. Okay, so our rule for Jordan was y equals x plus 10. That was for Jordan. All right, and so what are the number we're trying to find how many apps he would have on his phone based on the number of pre-installed apps? Well, we don't know how many apps were pre-installed. I think a lot of you got tripped up on this because y'all kind of figured out y'all didn't have enough information, but the cool thing is that X is our independent quantity. So it doesn't matter what X is. X can be anything. So let's just say that what if Jordan had 0 apps pre-installed on his phone? Okay. If he had zero pre-installed apps, then the total number of apps that he would have after he downloaded 10 would be 10. Okay. And we're going to do the same thing. If he had 1 pre-installed app, he would have 11 total apps on his phone. And if he had 2 pre-installed apps, that means he would have a total of 12. Okay, X could have been any number you wanted to, but I just kept my number small, so my graph would be small. Okay, let's do Wendy. Wendy's equation was y equals x plus 12, so her rule for this table is going to be x plus 12. And same thing for the pre-installed apps. Let's just say Wendy had 0 pre-installed apps, so that one means she had a total of 12 apps. If she only has 1 pre-installed app, that means that her total will be 13. And then if there's 2 pre-installed apps, that means there's 14 apps on her phone. Okay. All right. So those are the two. Now your X's might have been different. As long as you have the same rule or equation right here, and your Y's are based upon what X is, they're dependent, right? Then you should be good. All right. Okay. So let's move on to the multiplicative tables. All right, let's do Jordan first. Jordan, it's going to pretty much work the same way as we did for the additive tables. So Jordan, his equation was y equals 149x. So we're going to put 149 in our table here as our rule, 149x. Okay. All right. And if let's put our x and y's. If x was 0, right? If he had 0 installed apps, how much would he pay? It'd be $0, right? And 1 would be 149. I guess I should put parentheses around these numbers. It's okay. I think you got it. 149. Sorry, it's kind of small. And then 2 would be, I think it was, help some people Friday. So 2 would be, what was it, 298, I believe. Okay. And then for Wendy, all right, I went ahead and fill out Wendy's table. So Wendy's was 99 cents X, right? And so same thing. My X's were the same as Jordan's, and we found out what the cost would be. Okay. All right, so that's it for part B. Moving on to part C. Okay, part C. Part C says graph the additive equations you wrote in part A on one coordinate plane, and on the second coordinate plane, graph the 2 multiplicative equations you wrote in part A. All right, so let's do the first graph with part A. We're going to graph both Jordan and Wendy's data on this graph. Okay, so you should have 2 lines when you are finished. Let me go ahead and make a graph real quick. Okay, and so yours should look something like, sorry, I know my lines aren't straight. Something like this, right? Okay, and so this is my y coordinate and x coordinate. Okay, let's look at my x's. I only go to 2 and 3 on Wendy's. So my x, let's see, what are we talking about? Let's go and label it. So I labeled the x's. The x's are number of pre-installed apps, and our y's are total number of apps. Okay. All right. So my x's only go from 0, 1, and 2. So I don't need to make my x-axis go very far in numbers. So I'm going to keep that there. And then on my y's, it goes to, looks like 14. So I'm going to go to 15. We could count by ones if we want to, but I'm just going to count by, let's do twos. Okay, so let me do that real quick. Okay, so my y's are my total number of apps. I counted by twos. They're intervals of 2. Okay, so that means 1 would be in between the 0 and 2, right? And 3 would be in between 2 and 4. Okay, all right. So let's go ahead and use what we have over here to graph this equation, or graph this chart. Excuse me. Let me move this up here. I'm just going to move this up a little bit. We know this is a total number. Okay. All right, so how are we going to get our information to graph? What do we graph? Well, we have our x and y coordinates here, values, so we can make those into ordered pairs. So here's what that's going to look like. So for Jordan, the first ordered pair would be 0, 10. 1, 11 would be the second, and 2, 12. Okay, let's go ahead and graph these. Let's go, we'll use green for Jordan. And we're going to make our line a little bit bigger because we like to make big dots. Okay. All right. So 0, 10 on my run is 0, but my jump is 10. So I'm not going to run on my X, but I'm going to jump up. So my first point would be right here for Jordan. That would be 0, 10. Okay. And then my second one is 111. So I'm going to run to 1 and jump up to 11. So we should be somewhere right in here. Okay. So that's 111. Okay. And then our third point will be 212. So let's run to 2 and we're going to jump up to 12. So it's going to be somewhere right here. Okay, and my graph doesn't look quite proportional when I say that as far as the gaps and how close things are, okay, because my lines aren't straight. But that's kind of the sense of where the line would go for Jordan, right? Okay, so a line there. Let me erase that. It's horrible. All right. Oh, man. It's a lot of erasing. Okay, and then let's do Wendy. Oops. Let's do Wendy. And this was 212. Okay. All right. Wendy let's just use this one for Wendy. So 212 will be my first one, 113, and then 214. Okay. I'm sorry, 012. 012. So 012 would be right here. We wouldn't run any on our X, but we would jump up 12. So 012. Okay, and then 113, so run 1, jump up 13, so maybe right there. And then 214, so run to 2, jump up to 14, so we're looking right about in there, so 214. All right, okay, and so, yeah, so Wendy's line would be somewhere like this, right? And then Jordan's line would be somewhere like this, right? If we connected all the points, yeah. Okay. All right. And so let me ask you this: are these lines proportional? Ooh. The question is, do the lines go through the origin? No, they do not. They do not cross the y-axis at the origin. They cross the y-axis at 10 and 12. So that means they are not proportional. Okay. Let's go ahead and do our last part of part C. All right, so we're set up my graph here. We have total cost of apps here and number of apps installed over here to the x-axis. All right, so I've already set our order pairs up, and let's see, our x's just go to 0 to 2. So let's go ahead and just do that same thing. So I'm going to do 1 here, and let's just do, let's see, it'll be 25, 50, 75, and let's just do 2 here. So that'll be correct. And then let's do on our y's, we go from $0 to all the way to $2.98. So let's count up to $3. We're going to count, let's do it by 50 cents. I think that'll be good. All right, so there's 25 and there's 50 and 75, and this would be $1 and $1.25, $1.50. Looks like I'm going to have to make my y-axis a little bit longer. $1.50. Let's see, 75. So $2 would be here. Yeah, let me make this a little bit taller. Okay, I think that's good. All right, let's go ahead and do our first one. So 0, 0 for Jordan. Jordan's dot is going to be right here. 0, 0 is right here at our origin. Okay, so that's good. We did that one. Let's see, 1 and 149. So let's run over to 1, and we're going to jump up to $1.49. So $1.49 will be right below $1.50. So we're going to say it's right there. So that's 149. And then finally 298. So let's run over to 2, and then we're going to jump to 298. Well, 298 is right underneath $3. So let's see, here's my line there. So it's going to be like right there. So 298 for Jordan. All right, let's do Wendy's, and we should be finished. All right, so Wendy's 0, 0. So again, we'll put another point right here for Wendy. 1.99. So we're going to jump 1 and go up to 99 cents, which is right underneath $1.99. It's my order pair there. And my last order pair is 198. So we're going to run 2 and jump to 198, which would be right underneath $2. So 298. Okay. All right. If you took the time to watch this and check your answers, I really appreciate it. This will help you tremendously for the test. Also, are these lines y equals Y equals 149x and y equals 99x. Are those proportional lines? Well, they go through the origin, so yes, they are both proportional. Thank you for watching and have a great day.